Now, do me one favor. Make sure you like, you share, but more and more, make sure you subscribe to my YouTube channel. Teacher Kyle Explains. It contains a lot of things, especially that are meant for our learners in school. Now, without much ado, let's go directly into our class. Thank you. Wow, thank you so much. Now, in our class today, we will be looking at the temporary physical change. We'll also be looking into the temporary chemical changes and also in the permanent chemical changes. These are the changes which do take place when a substance is heated, which you need to take into consideration because it is very much important for any chemistry student because they are very important for our chemistry. The first thing that you need to understand is that copper 2 sulfate can never undergo temporary physical change. Cobalt 2 chloride cannot undergo temporary physical change. It can never, because we are saying that these ones here, we will learn them more in the second part of our process on the temporary chemical changes. Hydrated means it has water, and hydrous means it has no water. When an hydrated copper 2 sulfate undergoes heating, it will change its color from blue to white. But what you need to understand is that for temporary physical change, it is easily reversible. It is easily reversible. That means that you can go backward, you can go forward. There is no change in mass. If you are to measure the mass, be it maybe 0.5 grams, it will still remain to be 0.5 grams. It cannot change. It's very important for you to understand also that there is not accompanied by the net heat change. That means that the moment you do your heating, heat cannot be evolved, heat cannot be released. At the same time, there is no net heat change that is accompanying the process there. Therefore, if you are to consider copper 2 sulfate or cobalt 2 chloride, these two, for the temporary chemical changes, they undergo the net heat change. But for the temporary, they do not undergo it at all. What is the color of an hydrated cobalt 2 chloride? It's white. When it is anhydrous, it is pink. And therefore, you need to understand that during the heating process, a decomposition of a substance by the application of heat is what we refer to as thermal decomposition. Thermal decomposition, which is very important, especially when you are talking about the net heat change accompanying a substance when it is heated. Therefore, understand thermal decomposition is very important. That one cannot take place in the temporary chemical change. In the temporary physical change, pardon me there. Now, for the temporary chemical change, we are saying that we need to consider a certain substance that is if you are to consider copper 2 sulfate and cobalt 2 chloride, it's very important. But for copper 2 nitrate, this one here can be taken into the permanent chemical change. Somebody can ask me, there is copper, there is nitrogen, there is oxygen, and therefore during the heating process of this one here in the permanent chemical change, things do happen. We have copper 2 oxide, which is black in color, that is from blue to black, which you can actually consider. There is that nitrogen oxide, which is red brown, oxygen, which is colorless, as you can see there. These two are the gaseous product, and what you need to understand is that the moment you measure the mass of this product here, it is less compared to the mass of the reactant. Why? Because you are seeing that during the decomposition of this copper 2 nitrate, most of the gases are released into the atmosphere. Mass therefore changes, and it changes because they are gaseous product which have been released into the atmosphere, Very important for you to understand. Therefore, copper 2 nitrate, when it is heated, three products are formed: copper 2 oxide, which changes color from blue to black, nitrogen oxide, red brown, and oxygen gas, which is colorless, as you can see there. Now, this one here is not a temporary chemical change, though a new substance has been formed, but it is not a temporary chemical change. This one here is a permanent chemical change.
which you need to take into consideration. Heat energy is being involved in temporary chemical change, and also it is a reversible process. There is also a change in mass. There is a change in mass in the temporary chemical change, which you need to consider there. Now, this one is reversible, but if you are to compare with the permanent chemical change is irreversible. Now, the last part of our discussion is about the permanent chemical change in this process here. And the first one here, when we are considering the change in mass, for a good example is copper 2 nitrate. For copper 2 nitrate there's a change in mass. It is a irreversible process. Heat energy is evolved, or even also there is a change that is accompanied by the change in mass. A change is accompanied by the change in mass. That is what you need to understand. These three processes are very important to every chemist who needs to know about that.
Constituents of matter. Matter is made up.
Two things. Number one is that we are seeing what we call the elements, and we also have the compounds. Matter we can also get in a mixture, because we're saying that a mixture consists of two or more substances which retain their physical and their chemical properties. Now, this matter has been divided into two. We can have the elements and we can have the compounds. Elements and the compounds, in short, they are pure substances. That means there is no impurity in them unless you introduce it there. Now, these elements here, we are saying that they are pure substances which cannot be split by any chemical means. Compounds are also pure substances which are made up of two or more elements that are chemically combined. These elements have also been divided into two. We can have the atoms, we can also have the molecules. Atoms, the smallest particles of the elements which can take part in a chemical reaction. What about the molecules? It's also the smallest particle of an element which can exist separately. So a molecule, this one here, can exist separately, and this one here can take place in a chemical reaction, or some people can say, or your teacher there can tell you it's a chemical change, which is still okay. So matters be divided two. We have elements and the compounds. All of them are pure substances. So if you are asked an exam, what is an element, what is a compound? Element is a pure substance. Compound also is a pure substance, but elements are pure substances which cannot be split by any chemical means. Compound also is a pure substance. At the same time, you're also saying that this one is here also cannot be split, but they are chemically combined. Two or more substances, two or more elements are chemically combined. A good example is that if you are to consider iron and sulfur, iron is gray in color, sulfur is yellow in color. These two here, they are two independent elements, but because of heating process, we are saying that you will heat and it will form what we call a compound. So therefore, the compound of iron 2 sulfide will be formed. This reaction here is what we call exothermic reaction. In other words, there is a release of heat. There's a release of heat. When the heat has been released, that means that you can actually say that heat has been released into the environment. So we can have endothermic and we can also have exothermic. Endothermic heat is absorbed, while exothermic heat is released into the environment. Now, elements can be divided into three. We can have elements that end with IDE, for example, iron 2 sulfide. We can have the elements that end with ATE, that is, for example, sodium sulfate. We can also have elements which end with ITE, for example, sodium sulfide. So you can actually see this for sodium sulfide here, oxygen is present. Here also oxygen is present, but oxygen here is in high quantity, but oxygen here is in low quantity. So sulfide, low quantity. ATE, high quantity. IDE is made up of two elements. For example, if you talk of sodium chloride, how many elements are present there? There are two, sodium and chlorine. Not sodium and chloride, but it is sodium and chlorine. We also have iron 2 sulfide. How many elements? There are two, iron and sulfur. It is not iron and sulfide. Now, make a guess to this one here. This is a carbon
to nitride. How many elements are there? Carbon and nitride. No, it is carbon and nitrogen. Very good. For ATE, we are saying that, for example, if we have sodium sulfate, that means we have sodium, sulfur, and oxygen. We also have calcium sulfate. That means we have calcium, sulfur, and oxygen. We have sodium carbonate. We have sodium, carbon, and oxygen. Very nice. In sulfite, we have sodium sulfide, sodium, sulfur, oxygen, calcium, sulfur, and oxygen, and many more. Now, in the chemical symbols, you need to understand one thing. Elements can be represented using the symbols. Those symbols are letters. They can either be in English, like your English there in your school. We can also have Latin, but are you being taught Latin in school? No, but I can show you in this class. For example, a Latin name for potassium is kalium. A Latin name for sodium is natrium. That of copper is cuprium, and all that one. Wow, it's all good. Latin, it's a good language, right? You can also enroll for those classes I can teach you. Anyway, I was kidding there. So English and Latin, these two here are mainly used to give you the chemical symbols of those elements. Now, let us join again together in the next class.
Have you subscribed to my YouTube channel? Please, if not, do it once again. If you cannot do that, you won't see me. Thank you.